In this episode, we have Martin, our managing director, and Håkan, our simulations expert, that will show you how to retrieve greener castings with our new and improved standalone program, Good Guys Index. And Martin, NovaCast is all about contributing to a better environment and to a more responsible founder industry, and everyone must contribute to this. How would you say that the Good Guys Index has played out for customers and partners?
I would say one of our main action has been to build up the values in the company, and part of that has been to build up a Good Guy Index, which is an index that you can calculate that shows the environmental footprint. This goes back more than 6 years. Since then, we have further developed the software and the calculation. So we're not only calculating Good Guy Index, we're also calculating the CO2 emission and the cost for the product, so the production cost. Practically, what does it finally cost is really what we calculate, both environmental cost as well as real production cost. This is now a standalone program that can be used by many people in the organization. As our development partner Grundfund mentioned, it is not only for foundry technicians, it is also useful for purchasing and the environmental department.
And shortly described, what does the program actually do?
You can say, simply put, it calculates the CO2 footprint from the raw material to the finished good at the customer. This is as we see it, one of the jigsaw pieces that is necessary to fulfill an EPD, Environmental Product Declaration. And that will come, I'm 100% sure. We believe that the EPD, the Environmental Product Declaration, will be a competitive edge for our customer and will be necessary for our customer to calculate to get the orders. So please have a look at this presentation of our software, and I'm 100% sure that you would like to explore the software to solve your environmental and somewhat your financial challenge in the future.
Yes, and Håkan, our simulations expert, will show you the new and improved Good Guys Index.
Welcome to a demo of Good Guys Index program. Good Guys Index is a program for calculating of, for example, the CO2 emissions, but also the cost calculations and energy consumptions. The program is built, as you can see here. This is the project editor. Here is where you have most of the information, but it's gathered in other modules as well. You can then create and open projects here, and we have also some settings data here where we can set up. And we have a specific menu here, so this is the project editor as we are in. We have the process editor, which is a process where you can find the different processes, and that's the surrounding processes to the casting process. We can describe it better and calculate the CO2 emissions for them as well and cost. And then you have the path editor, which is actually a transport calculation out of CO2 emissions, not the cost, but CO2 emissions. And then you have a settings module. And we will start to look in the settings module first. In the settings module you can decide a little bit which method you are going to use, HPD or gravity. We can select gravity here. We are going to use gravity. We have some settings also for, if you are using the imperial system or the metric system, for example. We can also, and we have also some preset different furnaces, types of furnaces for different processes. Like for steel we have induction and arc furnaces. But you can also add your own and add the energy consumption and the emissions, CO2 emissions from it when you are doing the melting process. And we have that for steel, grey iron, ductile iron and aluminium for the moment. And you can add your own things there. We have the CO2 emissions as well, and the CO2 emissions is both done for the energy consumption, the electricity, for example, how that is produced. And here you can see that you have figures for nuclear, hydro, wind, solar power, natural gas and coal. and of course code is the worst part of it. You can also edit an energy mix, so you can set up exactly how you are buying the electricity to your company. And then you have also got emissions for different types of freight. It's ship, train, truck and plane for the moment. We can add maybe some others, or maybe it has to be different types of trucks, for example, in the future when we go into electric trucks, for example, or if it's different trains and so on. This is something that we are going to develop further on later on. But you can change your values and use the values you think is the best. We have taken these values from a certain source. I will not mention that here, but we have a certain source from them. You have also got default values here, and there are project default values, which is something that we have set up, for example, material cost, melting cost and so on. That is on the side, as I showed before. And then we have iteration default values, each iteration. And then we have also for the process editor, we have a possibility to add also step default values if we would like to do that. Then we'll go to the process editor. And the process editor is then if we, for example, would like to create a process, we have to actually first start a project. We will open a project, open project, and we go to desktop here and we open a gravity example project. So now we have a project here. When we have that opened, we can then go to the process editor again, and then we have some predefined processes here. We can also create some processes here. For example, if you create from template, we have 3 different. So we have investment, gravity and HPD. Of course you can create your own, you can set up your own, you can save them. So you can actually do your own templates in the future. But here we have, for example, for gravity. So here we have shakeout, cutting feeders, grinding, shot blasting, heat treatment, shot blasting again, and then machining. And then it is for input data here, machine cost, manpower cost, energy usage, and then time per part and man hour. And then we have the results, and then we have the CO2 emissions, depending on how much energy usage you have per part. So, and also it is possible to remove a duplicate. You can also change order if we like to do that. So it's very easy to make your own schedule here. And if you take a look at the investment costing, it looks of course different. So this is just an example how it could look like. But then I think you can easily from this find out how you should do it yourself. And you can make a new process, create process or import process. So if we then go to the path editor instead, the path editor has also some possibility to create paths. So you can go in here, for example, and from a certain template you can create something. We have a couple of templates for a moment, but you can also take a look a little bit on, for example, here, China to Sweden. So from the factory to the harbor, truck, certain distance, and then to Europe is by ship, certain distance, and then to Sweden, when it has arrived to the port, it's train first and then truck to the final position then. So then you can calculate the CO2 emissions for different transports. And for example, Express USA, here we can have to airport to USA final and so on. But also you can of course create a new, so we can make an empty here, next finish, and then we can go in here and say that okay, this one is the one we would like to add. Then we can go in here and then we can say from to Ronneby, for example, and it is then manufactured somewhere in in Småland, as it's called, the landscape here in the next landscape near to Blekinge. Then we say that okay, that is by truck. So if we would like to have it delivered here, we will then have, as you can see here, 5.11 kilograms per ton in CO2 emissions. And then that is then of course recalculated in a way that it will be depending on the amount of kilograms that is actually the part weighs. So going back to the project editor then. First of all, we have the input values here. So you can see the different input values here. We have a couple of basic things. We need to have the part weight, the feeder weight, the in-gate weight, and from that we can then have a total weight, and of course we would like to also add the mold weight. So the total weight is then used in order to calculate the casting yield. And the casting yield is something that is really interesting, I would say, to be able to improve that, especially for different types of gravity casting. They are using a lot of casting yield, but I think others could also gain from looking at this. And then we have the liquid temperature we have to put in. Everything here could either be imported directly from Northern Solid, but nowadays this is a standalone program, so you can import it yourself. So you can add, as I showed, we had create iteration, for example. If you have an iteration, you can create it directly from here. So that's not a problem. I have already created this. Then you can see that we have also got energy source, furnace type, process type, and transport path here. So what we can do is that we can actually play a little bit with this. So we can say that okay, we have coal, hydro, mix, and you can see that it affects quite much on the CO2 emissions here. And we have different furnaces. So if we change the furnace back to induction, it will change also the efficiency. So it will be a little bit less efficient. So arc furnace is better, as you can see here. We can also play a little bit and say that okay, this is investment casting, and that should be more expensive, as you know, because it's more expensive casting method. So that should be quite much more expensive, and you can see that it is also. Then we have also, for example, we can send it to US, and then we can see how that affects. So it is quite easy to compare different ways of the casting process. It could be comparison of different foundries. It could be comparison between different ways of casting it, or different ways if you are buying your energy from another place, or you're buying, for example, a better furnace, or you are doing it with another process, and so on. We have to also implement the casting temperature, so that comes in here. So the casting temperature is quite important. It is important because we are using this information to calculate how much over the liquid temperature we are actually. And then we get some results down here. It is energy savings, production cost savings, we have total cost savings, and then we have energy CO2 emissions in different ways here, and then we have production of the CO2 emissions and the production of the energy, and then we have freight, and then we have the holding energy consumption, and we have the energy consumption in total, and then you have electrical cost, production cost, and total cost of the part. And down here you have the CO2 emissions. The last point is the good guys index here, and the good guys index is then reflected quite much onto a couple of factors. It is the yield that is the best is to have 100% in yield, which is more or less impossible, but impossible is something that you can try to achieve anyway, or at least get near to it. Then we have the liquids, the temperature over the liquids, that is one of the things. We have the scrap rate and melt loss included here, and we have also the source of energy, which is also reflecting this quite much. So the good guys index is something that also The best is 100 then, to get up to 100. But I think it's a way to measure how you could be improving your process. So improving all the time your processes in order to be able to get to a higher value. And then you can use this as a measurement. The CO2 emissions is something that you know that is a fact. The Good Guys Index is something that we have invented as a number in order to summarize some things we think is very important in the process to measure. You also have the material cost that you can change here, and the melting cost, and you also can take into account pattern cost and pattern estimate life. They are more important for high pressure die casting, I would say, than it is for gravity casting. And then you have the pattern weight and so on. As a last thing, I would like to say something about why you should use Good Guys Index. You can obviously use it for improving a specific cost by improving yield and so on, and visualize it in a proper way then. So you can really see what differences it makes on the cost and the energy and the environment if you are changing your casting yield. You can also use it in order to improve your general performance in the foundry on all types of casting. So you are using this Good Guys Index and CO2 emissions in order to try to be better, to try to be giving a better performance from the foundry and the castings. You can also compare, if you are, for example, a purchase, you can compare different foundries on a specific part or project. So this could be foundry 1, 2, 3 and so on. So therefore you can see exactly what it does if you are buying a casting from Sweden, from Germany or from China or from Turkey. And there you can have the comparison, both on the cost level but also on the energy, the environment impact and so on, the environmental footprint. And you can see effect on use of different energy sources and mixes, as I said, and you can create your own mixes also as well. And you can see effect on use of different furnaces, especially if a foundry, for example, is going for improving the furnaces, buying new furnaces. Then you can see the impact. What does it do for you in the end? And you can compare casting of a specific part with different processes. So you can actually change and see if you have a part that is, for example, aluminium. You pour it in a gravity casting or gravity die casting. You try to do it with high pressure die casting, or you do it with investment casting. How does it influence both from cost perspective but also from an energy perspective and an environmental perspective?
Our friends at Grundfos, they have been a great partner in this development process, and they have been testing their technicians, their environmental and purchase departments and so on. And we are still in the need of more tests to be done in order to release this fall. How can we increase this?
That is absolutely true. We are at the moment testing our program in different situations and applications and projects, but we would be interested to increase our test base. So if you who have been listening to this and listen to this are interested to become a test pilot and test this program, you're absolutely welcome, and don't hesitate to contact us, and you're welcome to become one of our test pilots.
And that's it for this NCTV episode, and we will take a summer break. But don't worry, the NovaCast team will work throughout the summer to support you. Take care.